Okay, in continuation, in a small nucleus, the particles are close together so that the strong force holds the protons and neutrons tightly together. So we have learned in part 1 in the previous video that there is an electrostatic force that pushes the protons away from each other, but there is also a stronger nuclear force that holds them together. And aside from that, while there is no electrostatic force that exists between two neutrons or a neutron and a proton, but there is a stronger nuclear force that holds them together. But we have to remember that this strong force is only strong if the particles are close together. So if a nucleus is small, there are only a few protons and neutrons, so they are more held tightly together by the strong nuclear force. But in a large nucleus, the strong force holds together only the particles that are closest to one another. Kaya di ba kung dako ang nucleus, daghag proton, daghag neutron, so dili gid sila dugol, ang uban lagyo gyud. So ang kadung lagyo, walay strong force nga ni-exist between them. Okay, so since there are many protons in a large nucleus, the electric force repels protons that are far apart. So we have to remember nga ang kaning electrostatic force, even if layo mo, it will still try to it would still kanang work even if layo sila. So it will still try to break them apart. Mas mulagyo pag yun. So this increased repulsive force causes particles in a large nucleus to be held less lightly than those in a small nucleus. Kay here so kani mura ni ang nucleus, mura ni ang strong force. So kani there is a strong force between them. So kani nga proton layo siya ani nga neutron, so there is no strong force anymore. So kani nga proton ug kani nga proton lagyo sila, there is no strong force between them, but there is still an electrostatic force that is trying to break them apart. So they are held less lightly compared to the small nucleus. So this is another picture showing the repulsion between the protons and the attraction, because of the strong force between the nucleons. So we recall that each element has its own atomic number, which tells us how many protons there are in one atom of that element. So we use the variable capital letter Z to represent the atomic number. So if the atom is neutral, then this atomic number is also equal to the number of electrons. But we also have to remember nga kung neutral ra. Kaya kung dili neutral, then dili siya equal to the number of electrons, no? So kung ma-charge na ang particle, it becomes an ion. So the sum of the protons and neutrons is called the mass number, and we use the capital letter A to represent the mass number. So ato na hinumduman A, Z, M, A. Atomic number Z, mass number A. So if you look at your periodic table, the symbol is like this. So some periodic tables are written this way. So the number sa ibabaw is the atomic number Z, and kaning number sa ubos, this is the mass number A. So it's usually rounded off for some elements. So the atomic number Z, because the atom is neutral, represents the number of protons and the number of electrons, and the mass number A, so we just subtract from it the number of protons to get the number of neutrons. So we have to keep in mind the number of neutrons plus the number of protons is equal to the mass number A. And to be able to get the number of neutrons, so you just subtract the mass number A minus, of course, the number of protons. So for sodium, the atomic number is 11, meaning there are 11 protons and 11 nga electrons. So we round off the atomic number of sodium to 23, meaning there are 23 minus 11, so there are 12 neutrons. For oxygen, its atomic number is 8 and its mass number is 16, so meaning equal ang tanan number of protons, electrons, and neutrons for this oxygen. Okay, and this is also another term that's important in this lesson. So the term nuclide is referred to a single type of nucleus and is identified using the notation. So kanang element din ha. So nuclide, pwede na to i-present ana. So A here is the atomic number, Z here is the atomic number, A here is the mass number, and X represents any element. So here, mass number, which is equal to the number of protons plus the number of neutrons. Atomic number is the number of protons. And here, the capital letter X represents an abbreviation of any element. Alright, so this is another symbol showing us, meaning kanidi ay sa helium di ay na duha ka proton, na duha ka electron, and then there are also 2 neutrons. So it's just a small nucleus with an equal number of protons, electrons, and neutrons. Another term that we need to recall is that atoms of the same element, so atoms of the same element with the same atomic number but different mass numbers are called isotopes. So, di ba kung atom, they have different number of electrons, so it becomes an ion. So, ma-charge ang particle. So, this time, different iyang mass number, but you have to remember nga ang kanang number of protons dili kina siya ma-change. So meaning kay lahi man siyang mass number, and mass number is equal to the number of neutrons plus the number of protons, nya kaning protons kay di man ma-change. So kung lahi-lahi og mass number, meaning lahi-lahi dihay og number of neutrons, and they are called isotopes. So this means that the atoms have the same number of protons but they have different number of neutrons. They are called isotopes. Isotopes are substances, atoms of the same element but with different mass numbers because they have different number of neutrons. And different isotopes of an element are distinguished by their mass numbers. Of course, mass numbers because again, the atomic number will never change. So the nuclides of different isotopes are denoted by, we either use the entire word for the element dash the atomic number, or we can use the symbol kadong ganiha kaning annotation. So we can use this also, so you can indicate the atomic number here bottom left and the mass number upper left. And another thing, aside from these, you can also use the, it can also be denoted as kadong element na symbol niya dash 35 instead of writing the word good. So you can just use the symbol of the element dash the mass number. So this example here, it shows us the different isotopes of carbon. So you name this as carbon 12, carbon 13, and carbon 14. So actually baliktad siya because you have to put the mass number sa ibabaw. So it's carbon 12, 6, or carbon 12, carbon 13, 6, or carbon 13, carbon 14, 6, or carbon 14. Diba? So these are different isotopes of carbon, and as you can see, of course, mo differ ang ilahang, they have the same atomic number, the atomic number of 6, so meaning there are always 6 protons in each of these isotopes of carbon, but they have different mass numbers. So pila may number of neutrons aning carbon 12. So the number of neutrons here is 6, the number of neutrons here is 7, and the number of neutrons here is 8. So they have different mass numbers, they have different number of neutrons. So they are isotopes. Okay, so anong naghisgot man ta atong isotopes? A nucleus is stable if it cannot be transformed into another configuration without adding energy from the outside. Again, it is stable if it cannot be transformed into another configuration without adding energy from the outside or external, diba? Nga, kuan. So, of the thousands of nuclides that exist, about 250 are stable. So, meaning, it's very stable nga for it to be transformed into another configuration, into another, probably an isotope. So kinahanglan pa siya og energy, addition of energy para ma-transform siya into another configuration. But ningon gani dire, of the thousands of nuclides that exist, about 250 lang ang stable, no? So meaning there are thousands also that are not stable. So unsa di ay ng stability? When can you say nga stable siya or not? So the stability of a nucleus depends on the balance between the repulsive electrostatic forces and attractive strong forces, and therefore depends on the ratio of the number of neutrons and protons in a nucleus. Ang stability niya magdepende sa number of neutrons and protons, ang ratio niya. Kaya diba, the addition of neutrons will help add an attractive nga strong force para dili mo daog si repulsive force. So the lesser of neutrons, the more nga dili stable ang isa ka nucleus, no? So a plot of the number of neutrons versus the number of protons for stable nuclei reveals that the stable isotopes fall into a narrow band. So they were able to plot a graph niya, and they fall into a narrow band called the belt of stability. So in this figure here, so kani siya, this is the belt of stability here. So if ang atom naa siya ani nga linya, so meaning it is stable. And if you cannot find it here, then meaning it is not stable. So it has been found out that nuclei containing more than 83 protons are unstable, and in other words, there is no element beyond bismuth that has a stable isotope, kay 83 is bismuth man. So we can see here, kani mo man ang number of protons. So kani tanawa, so diri ra siya kutob, di ba? Wala na dayon blue na apil aning belt of stability. So meaning everything beyond ana niya, they're already unstable. So if less than 83 pa ang number of protons, there is still a chance that it is stable. So nadiha na below ang 250 nga stable. So there is also a pattern nga nuclei with an even number of nucleons, either proton or neutron, they tend to be more stable than those with an odd number of particles. No. Again, if they have even number of protons or neutrons, they tend to be more stable than those with an odd number of particles. Even. So, and also there is a pattern that certain number of protons or neutrons show exceptional stability. So kung naa sila aning, if there are 2 protons or neutrons, or 8, 20, 28, 50, 82, 126, their stability is exceptional. They're very stable. Okay. So the nuclei that are to the left or to the right of the band of stability are unstable, and they exhibit what we call as radioactivity. The nuclides that exhibit radioactivity are called radionuclides, and atoms containing radionuclides are called radioisotopes, meaning they are radioactive isotopes. And if they are radioactive, meaning they are unstable. So they either occur naturally or they are artificially prepared in the laboratory, kani mga radioisotopes. Na ay artificial, na ay natural. So unstable, because unstable, just like us, if we are unstable, of course we have to, unsa may buhaton kung unstable, it will seek stability. So ganahan magid ta ma-stable, di ba? So it will seek stability. And unsaon niya para ma-stable siya? Kaning unstable nga radionuclides, they will seek stability by undergoing antong gitawag og radioactive decay. So we will be talking about isotopes here that are radioactive. They will undergo kaning mga radioactive, they will undergo radioactive decay or simply decay to become more stable and produce another isotope. Okay, another configuration, isotope of another substance. So in this process, kaning sa radioactive decay, the unstable nucleus, it will break apart, producing a more stable nucleus and emitting particles and electromagnetic radiation. So, unsa to'y ma-produce niya? A more stable nucleus and particles. So, duha na siya ang ma-produce. More stable o particle. Nga mo, inig undergo niya og radioactive decay. The unstable nuclide that undergoes decay is called the parent nucleus, and the more stable nuclide produced is called the daughter nucleus. So, ato dyan nang gibalik-balik nga it is just more stable. It does not mean that it is already stable. It is just the daughter nucleus is just more stable than the parent nucleus. It is more stable, but it could still be unstable and it could still undergo decay, no? So the daughter nucleus could already be stable or may still be unstable and eventually undergo decay if it is still unstable. So when a radionuclide undergoes decay, it releases, di ba, katong ingon niya, particle, radiation, in such a way that the daughter nucleus produced lies closer to the band of stability than the parent nucleus. So of course, mulay siya closer to the band of stability because it is already more stable man, di ba, compared to the parent nucleus. So i-release niya aning radiation, mo na siyang mo closer siya aning band or belt of stability. So therefore, the kind of decay that a radionuclide will undergo can be predicted depending on its location relative to the band of stability. So kung ang nuclide initially naadiri siya dapita, it has like 50 protons and then there are 80 neutrons, so na siya diri. So meaning, unsa man nga type of decay ang undergo? Beta. Okay? Na siya diri dapita. Okay, so this is positron. Positron. Na diri dapita kaning yellow, alpha decay din na siya. So ma-predict na to kung asa siya, kung unsa nga type of decay ang iyang ma-undergo.